Okay, welcome to our last section from chapter 9, 9.3. Remember, chapter 10.1, 10.2 won't be on your test, but I believe there will be a checkpoint for 9.1. So you may remember from grade 11, you did a reactivity series of metals where you looked up or you looked on a list to see if an atom was more reactive than another. And if something was more reactive, it was tend to displace something else. So that reactivity series of metals didn't come out of thin air. It came from many trials and errors, or no, just trials of experimenting and determining what substances were more likely to react with others. So because we know that, it's easy for us to sort of not realize the validity of what the lesson we're about to do. But what we're actually going to do is predict whether a redox reaction will occur. And if it does occur, we say that it's spontaneous. And if it does not occur, we say that it is non-spontaneous. Sorry. And if it does not happen, it's called non-spontaneous. Spontaneous. All right. So what we're going to look at is I'm going to give you a reaction and I'm going to show you how you would determine if this reaction was spontaneous or not spontaneous. First thing we're going to learn is how we actually come up with a table of oxidizing agents and reducing agents and how strong they are. So let's say we studied a bunch of metals. I took some magnesium metal and I put it in a solution that contains silver. And I put it in a solution that contained nickel, and I put it in a solution that contained lead. And I found that the magnesium reacted with all three of those. Nickel, on the other hand, will not react with the nickel solid, will only react with the silver and the lead. It will not react with a solution containing magnesium ions. Lead, a solid piece of lead, will only react with the silver. So we can determine from that which of these metals, which of the solid metals is the most reactive and which one is the least reactive. So from this, I wrote down all these data points and I said, well, magnesium reacts with all three of these solutions. So you can kind of think of it like this. You have a piece of the metal and you are putting it into a solution that contains silver ions, for instance, and you're checking to see if it reacts. And in this case, it did. And then you're putting it into a different solution that contains nickel ions and to see if it reacts, and it did. And then you're going to try lead ions and you're going to see if it reacts. And in this case, magnesium metal reacted with all three, nickel reacted with only two, lead reacted with only the silver, and silver reacted with none. So you can easily figure out that the magnesium metal, is the most reactive and the silver is the least reactive. So that's what we've done here. Now I'm going to take those reactions and we're going to change them into half reactions. So magnesium solid, if it reacted, that means it would have changed from magnesium solid into its ion. It would have lost some electrons to become from magnesium solid to magnesium 2+ with 2 electrons. This was the strongest, what we call strongest reducing agent. Remember, a reducing agent causes something to get oxidized. So in this case, the magnesium, because it lost electrons, lose electrons is an oxidation. So it got oxidized. That makes it a reducing agent. Metals tend to be reducing agents, okay? Non-metals tend to be oxidizing agents. So we can list these half reactions of the metal, the solid metal turning into its ion. We can list it from the strongest ability to react, we'll call it the strongest reducing agent, to the weakest out of these 4. Now, obviously, there are a lot more metals, and obviously, we didn't do all the metals. We only did 4, but all the metals have been tested, and there is a list of all the metals from strongest reducing agent to weakest reducing agent. It's on that orange piece of paper that I gave you. we can do the same thing, but reverse. This time I can take a solution and record it sort of the opposite way. I've got a solution with silver metals in it. I'm going to put some magnesium metal in it and see if it reacts, which it does. I'm going to put some nickel in it, solid nickel, which it does, and I'm going to put some solid lead in it. So for silver ions to react, they would have to gain an electron, and they would become silver solid. When they gain an electron is a reduction. These guys would be oxidizing agents. So metal ions tend to be oxidizing agents. Metal solids are reducing agents, but metal ions are oxidizing agents. So we can list these in order from strongest oxidizing agent to weakest oxidizing agent. So the silver ions reacted with all three metals, the lead only with two, the nickel with only one, and the magnesium with none. So we've now listed the strongest oxidizing agent to the weakest oxidizing agent. But look, magnesium here, this one was our strongest reducing agent from the previous slide. So on this side, we've gone from strongest oxidizing agent to weakest oxidizing agent. But if you read the reverse, it's the backwards. The strongest reducing agent is down here, and the weakest reducing agent would be up here. I'm getting ahead of myself. But you could combine these two tables, and you end up with this table. This is a table of reducing and oxidizing agents. You list the strongest oxidizing agents in this top corner here, and the weakest down here. But the weakest oxidizing agents is now the strongest reducing agents. So you can read this side or you can read that side. Depends on what you're looking at. So I've given you this, a good copy of a redox table. It's on that orange sheet. The one in your textbook is terrible. It has mistakes in it. Use the orange sheet. And on the orange sheet, I have noted two particular reactions. Water shows up a lot in all of those reactions, but there is only one half reaction where water is oxidized. And there is only one half reaction where water is reduced. And I have listed them both on that table. So, and they're marked with a star or a line. So that's important when you're trying to predict if a reaction is going to take place. Okay, so what do? When you have a redox reaction, you're going to list all entities. You are going to identify all the oxidizing agents and all the reducing agents. And you can just look them up on the redox table. And then of all your oxidizing agents, you're going to find your strongest oxidizing agent. And of all your reducing agents, you're going to find your strongest reducing agent. And you're going to look them up on that orange piece of paper. Okay? If your strongest oxidizing agent is above your strongest reducing agent, the reaction is spontaneous. But if your strongest oxidizing agent is below your strongest reducing agent, the reaction is not spontaneous. It's not going to happen, won't occur. Okay, so nothing will happen. And I'll give you an example, like if I drop a bar of lead in a solution of hydrochloric acid, will a reaction occur? You can break that down into all the entities and you can find them on your on that redox table, and you can identify if a reaction is going to occur. So let's try one, and then I'll leave you to go do some practice. Okay, so this is a sample on page 621 of your text. It says nitric acid does a redox reaction occur if copper metal, so will a reaction occur if copper metal is placed in a solution of nitric acid? Okay. All right, well, let's figure that out. And if it's yes, I want you to write a balanced redox reaction. And if it's no, then you can't. Okay, I'm going to change to blue. All right, so the first thing you're going to do is identify everything in solution. So we have copper, which is solid. It's in solution, so there will also be water, right, which is a liquid. There will also be nitric acid, which is HNO3. It's okay if you don't remember what nitric acid is. I would give you those solutions. Now, nitric acid is a strong acid, so it's important for you to realize that this is going to exist as hydrogen ions and nitrate ions. We have to look at them separately. So those are the four things that are in there: copper, water, hydrogen ions, and nitrate ions. So let's look at your redox table and find where these things sit. I'm just going to flip to a redox table because I don't even have one. Orange one handy. The one in your textbook is kind of split up and it's not, I don't love it. Okay, so if I look at, oops, actually, you know what I'm going to do? Okay, so you have to look up all of these entities on a reduction table, on a standard table of standard reduction potential table. So I have one. If you have a look, you have that orange sheet. It looks kind of like this one. I actually couldn't pull up the exact one. So we're going to find copper solid. You're going to find copper solid way down here. Of course, I can't find it now. Oh, here it is. So copper solid is right here. So it's going to be a reducing agent. So everything on this side is a reducing agent. Everything on the right is a reducing agent. Everything on the left is an oxidizing agent. So copper is here as a reducing agent. So you can go back and you can list copper as a reducing agent. The nitrate ion is up here. It's an oxidizing agent. Water comes in two spots. So water is on this table one time, and I don't know, I hope you can see my pencil. Water is right here at the plus 1, 2, 3. In this point, water is a reducing agent. Notice there's water in lots of equations, but there's only one where water is the reducing agent. That's right here, and I've listed on your sheet. And there's only one way down here where water is the oxidizing agent. So it's right down here. So you're going to take your table and you're going to identify which one is the strongest oxidizing agent and which one is the strongest reducing agent. So if I look at all four of those entities, I will see that the oxidizing agents are going to be the NO3, the H plus is an oxidizing agent. It's listed on the oxidizing agent plus, and water is an oxidizing agent. It's both, right? Water is an oxidizing agent. So you're going to write out those three equations that have those particular ones, or you can write them out, or you can just pick the one that's the strongest. So you should find this, and then this was an electron potential of plus 0.8 volts. The H plus, this one is always the 0 one. Oops. And then water, 2 waters gaining 2 electrons, producing hydrogen gas and 2 hydroxide ions. And this one was negative 0.83. So of our oxidizing agents, which were these 3, so this was an oxidizing agent, this is an oxidizing agent, this is an oxidizing agent, this is a reducing agent, and this is also a reducing agent. So of these 3, which one is our strongest oxidizing agent? It's going to be the one that's the highest. So this is what's called my strongest oxidizing agent. So I don't have to worry about these at all. I only need my strongest oxidizing agent. And you don't have to write out that whole equation yet. You could have just picked it out. Now, of my reducing agents, I've got water and I've got copper. So which one is stronger of water and copper? When you look on the table, copper solid is at plus 0.34, but water as a reducing agent is much higher. It's 1.23. So my strongest reducing agent is the copper. Copper 2 plus 2 electrons. Now these are how the reactions are written. And the electron voltage is 0.34. So this is my strongest reducing agent. So is my strongest oxidizing agent above my strongest reducing agent? Yes. So the reaction is spontaneous. Now, what you have to do is put these two together and actually balance them. And if nitrate is going to be your oxidizing agent, then copper is going to be reduced. And so you have to actually flip copper's equation, because copper didn't go in as an ion, it went in as a solid. So when you put these two equations together to balance them, you have to flip, because we started with copper solid and it turned into copper 2 plus and 2 electrons. So now you can put the strongest oxidizing half reaction, this reaction, together with this reaction, together with this reaction, and go ahead and balance them. You want to balance them for charge and you want to balance them for atom. So you might have to, looks like you might have to multiply this equation. I'm going to leave that for you to try to figure out. That's page 621, that example is given. But to come up with your final balanced redox reaction, you will have to combine the reaction of your strongest oxidizing agent and your strongest reducing agent. And if the reaction is not spontaneous, you wouldn't actually have a balanced redox reaction to have to balance. Okay, I hope that helps. You should be able to do 9.3. You have to practice some questions from 9.3. There's worksheets and there's textbook questions. And when you're ready, you can do the ISU checkpoint online.